I want to show you a real quick video on simplifying square roots. So I know you know things like the square root of 25 is 5. The square root of 81 is 9. So when you're square rooting something, you just think about, we know that the square root of 25 is 5 because 5 times 5 or 5 squared is 25. But what if you have to simplify the square root of 28? Then what? It's not a perfect square. So there is no number that if you square it, you get 28. So probably a lot of you would know you could take your calculator and we could say, all right, well, it's approximately 5.29, but that's not exactly 5.29. We can see that. This is an irrational number. We also know that it has to be between, even without the calculator, we know it has to be between 5 and 6, since the square root of 25 is 5 and the square root of 36 is 6. So we know since it's the square root of 28, which is in between 25 and 36, we know it has to be in between. But though that's not exact either. How do you simplify a square root exactly? So what I'm going to have you do is think about a list of perfect squares. So 1 squared, 2 squared, 3 squared, 4 squared, etc. So I'm going to make a list here. And I'm just going to go up to 100. And when trying to simplify the square root of 28, you want to find the largest perfect square that evenly divides into 28. So if you look at this list, obviously it has to be less than 28. So 25 doesn't go evenly, 16 doesn't, 9 doesn't, but 4 does. So you're going to factor this as the square root of 4 times the square root of 7. Well, we know the square root of 4 is 2. So we get 2 root 7. And that is an exact value. So if you're asked to simplify a square root and we need an exact value, this is what you would say. Now you can check your answer, because if you type in 2 times the square root of 7 and you don't even need the times sign, it's implied, you can see that you get the same decimal approximation. So we typically don't say 2 times the square root of 7 because we like to take shortcuts. So we say 2 root 7. So what if you're asked to find the square root of 108? All right, well, that's a little larger, but you have this list here, so just take your calculator and try a few things. So maybe you want to try 64. Well, I know it can't be 64 because 64 times 2 is larger than this. So let's try 36. Well, 36 goes 3 times. So I'm going to break this down to the square root of 36 times the square root of 3. So the square root of 36 we know is 6, so we get 6 root 3 is what this would simplify to. All right, and again, you can double check by taking the square root of 108 and comparing that to 6 root 3, and you'll know you're right. So then what about the square root of 2,880? Now you don't generally have to do things that large, but what if you did? So if we looked for the largest perfect square on our list, and I'm going to try 36 again. 36 goes 80 times. Okay, so let's go with that. Let's say we know the square root of 36 and the square root of 80. So the square root of 36 is 6, so we're going to get 6 root 80. But then I have to ask myself, is there a perfect square that also goes into 80? So I can look at my list and see, do any of these go evenly? I'm going to try 16. And it does, it goes 5 times. So now I'm going to break down the 80 to the square root of 16 times the square root of 5. And the square root of 16 is 4, so I get 4 root 5. Remember that this is multiplying, it's implied, even though we don't have to use the times sign, which meant this was multiplying too. So the 4 that I have here has to be multiplied with this 6. So my answer, 6 times 4 is 24, so I get 24 root 5. Now if I had known that 24 squared, would have been a perfect square. But it's okay to do it in 2 steps, especially when you have a large number. So you might find a perfect square that goes evenly and simplify it, but then take a look at what you have left and see if you can simplify that some more, because you might need a second step.